Hello everyone. So in this video we're going to go over two additional examples of both weighted mean and then mean of group data. But we're going to look at the first one slightly differently than we did in class. So if I take a look at the example here, we have a breakdown of the grade, so each category is worth a certain percent, and then we have her total grade in each category. Okay, so but this one's asking, if you read carefully, what does her test average need to be in order to get first honors? Because you notice that we're missing the test here. So what does her final average for the test need to be in order to get a 90 or above? Okay, so remember when I'm calculating weighted mean, well, first off, for note-taking purpose, I was like breaking down what I have here. So we could write each of our categories here. Okay, so for weighted mean, we multiply each category times its respective weight. So for 92, that's the homework grade, which is worth 25% of the grade. So when I'm doing mean, my symbol should be X bar. Right, so I could do the 92 times the homework is 25%. All right, and then quizzes are 15%, and she got an 81. So I could add on the 81, which is worth 15%. Projects, she got an 88, and that's worth 10%. So 88 is worth 10%. And then finally, we have the test grades, which are worth 50%. And I don't know what the test grade is, so what should I use if I don't know what the test grade is? Right, so math, we should use a variable. So I could just use X here, so that's what we're trying to find, and then that tests are worth 50% of the grade. So the majority of the grade, basically half of the grade is just the test there. Okay, so notice I want this weighted mean to be, I want to know what she needs to get in order to get a 90 or above. Okay, so what inequality symbol would I use for 90 or above? So that would be at least, right? So 90 is the minimum, or anything higher than that. So 90 or better, so I need this to be at least 90. All right, and remember when I do my weighted mean formula, I divide by the sum of the weights. But here, since I already moved the decimal back twice, what would the sum of 0.25, 0.15, 0.10, and 0.50 be? Well, that would be 1, right? So I know I would have to divide by 1. But in our formula, remember to divide by the mean of the weights if it's not percentages. But we could do it this simple way here. Okay, so let's go ahead and type this in. So if I go into my calculator here, I could type in the 92 times the respective 0.25%, the 81 times the respective 15%, and the 88 times the respective 10%. Alright, so that'll give me about a 43.95 plus this, I'm going to put the number in front of the X, right? More looks better that way. And then we want this to be at least 90. Okay, so if I think about this equation here, how would I solve for X? So my first step would be to, well, X is here, so it's attached by this plus 43. So to undo that, we could do a minus 43. Okay, so we could subtract that 43 from both sides, get rid of that. So we'll get 50x greater than or equal to. So if I do this subtraction, you should be able to do it in your head, but just in case not, you could type it in as well. So we should get 46.05. Okay, so then finally, a few different ways you could do this. So obviously you could do it the straightforward way. It's 0.50 times x. So to undo multiplication, you could divide both sides by 0.50. Or 0.5 is the same as 1/2, right? So if you want to think about this as a fraction, to undo a fraction, you can multiply by the reciprocal. So to undo 1/2, I can multiply by 2/1, or just 2. So basically I'm doubling each side, because then that'll go away. So we'll be left with 1x, or just x. So it looks like that test average needs to be at least, if I double that, that's double that, that'll be 92. And if I double 0.05, I'll get 0.10, or just 0.1. Okay, so I have to get at least a 92.1 on the test average. And just to put this in context, we have to think about what that means, because if it is a single test, teachers are not really going to give you 92.1, so that would mean she'll probably have to get a 93, unless we're assuming if she gets like an 89.5 or 89.9, the teacher would round up to a 90 because the rounding rules. So then we would adjust our formula to even make this 89.5 if we do that. But we're not going to think too deep about this. We'll just circle this as our final answer. So that would be the final test average. So for example, say she had 2 tests in the quarter and she already got like a 96 on one. So the total test average would be a 92. So if she already got a 96 on one, She's 4 points above it, so the other test you would have to be 4 points below. It's like an 88. And then this would average out to a 92. So it could even go deeper the question to dive into that test category. So that might show up as well. All right, so moving on. So I want to look at an example of group data. So looking at this frequency distribution, I didn't give you the tally column or the class limits. I just gave you the boundaries of frequency. So we can talk about this. So by first looking at this, what would my class width be? Okay, so remember when I have the boundaries, I can subtract the 9.5 minus the 2.5. So you can simply subtract the boundaries to get your class width, minus 2.5. And notice if you do lower minus lower here, it's the same 9.5 and 2.5. So our class width would be 7 here, which is odd, which is good, which we like, because when we do our midpoints in a second, we do want whole numbers. Okay, so if you remember, our formula for group data is to find the mean. Let me do this in a different color, actually. We want to do the sum of the frequency times the midpoint over. You could write the sum of f, or we just call the total number of values we have as n. But if you want to do sigma f, that would be also acceptable. So which means we have to do the frequency times the midpoint and then add them all together. Right? Sigma means just sum them up together. Okay, so we need the midpoint. So we'll make a column here for the midpoints. Okay, so what would the midpoint of this first class be? Okay, so remember to find the midpoint, I could add the limits or the boundaries, the end ones there, so I could add them and then divide it by 2. So this would be 6. Right, or if you look at this, this class would be from 3 to 9, right? If you go 0.5 back and 0.5 forward. So 6 would be in the middle here, right? 3 this way, so 6 is in the middle. Okay, we know our class width is 7, so I can go add 7 down. So 6 plus 7 will be 13. Add another 7, that's 20. 27, and then add another 7 is 34. Okay, so once you have your class width, you can simply add down. Okay, so remember our column that we ultimately need, we need frequency times each midpoint. So I'm going to make another column here, so the frequency times each midpoint. Okay, so the lower numbers are pretty straightforward. So 5 times 6 would be 30. 7 times 13, so that would give me 91. 6 times 20, you get it in your head, that's 120. Then we get 27 and 3 is 81, and then 136. Okay, so we ultimately want the sum of this, so my sum of my frequency times the midpoint. So if I sum these all together, what would I get? Okay, so if you type this in, we should be getting 458. Okay, and if I ask myself what's my n, so how many total values are in my frequency distribution here? Okay, so remember the frequency, this is how many are in each class. So if I sum this together, n is my total, always my sample size and number of people I have, and for number, we should get 25. Okay, so once you have this, these columns are the work, the hard part. Once you have this, so we could simply plug it in. So my sum of the frequency times the midpoint would be 458, and then my n would be 25 values. Okay, so if I do that division, what would my final answer be? Okay, so we should be getting about 18.32. And then if it's we have what the values mean, we could put units, maybe grams or degrees Fahrenheit, whatever the units are, but I didn't really tell you that, so that's fine here. And if you think about what we're doing here, this is just an estimate of the mean, because remember, we're grouping the data, so we don't know what values are in this class, for example. So this 3 to 9 class, all the values could be 3, right? 3, 3, 3, 3, 3, and they'll still be grouped in this class. But we're finding the midpoint, so it's about 6. We're assuming hopefully some of the values are higher than 6, lower than 6, and then it'll average out. So we're putting sort of the middle of each class, hoping that it averages out. But if we're unlucky and all the values are on the higher end of each class, this would be a underestimate, right? Because if all my values are near the upper boundary, we're assuming just the midpoint, if that makes sense. So this is more of an estimate, not exact, like our other mean formulas. But generally, that's how we'll handle group data. All right, so that is all for this video. Hopefully we take notes. Hopefully this was helpful. Thank you for watching.